Lesson 7.3 is about laws of logs. So what you want to realize is that there are three laws. There's the product law. So the product law states that whenever you see addition between two logs, you can actually multiply the numbers that follow the log. So log of base 10, if you don't see it, all you're doing is you're saying that with the 12 and the log of 2, you're actually writing it as log of 12 times 2, and so that would be log of 24. So if you were to evaluate log of 24, that would be the same as adding log 12 plus log 2 by itself. Our next example is the quotient law. The quotient law states that if you have subtraction between, what you're going to do is divide the two numbers that follow the logs. So that can only happen if the base is the same. So what you're doing is you're saying 12 minus log of 6 is equal to log of 12 divided by 6. So whatever comes after the subtraction is going to go to the denominator. So really what that means is to simplify, you would write it as 12 divided by 6 is 2. So you're writing it as log of 2. And the last law is your power law, stating that whenever you have log of 2 to the power of 4, for example, you can rewrite it as 4 in front of log 2. So you can bring that power in front to be a coefficient instead. So it's just about moving that power in front. So that is the power law. So what we're going to do in example number 1 is we're going to simplify, and then we're going to evaluate the answer to the nearest thousandth. So we're going to start by always bringing the coefficients to power spots. So all these numbers that are in front need to come into the power for you to be able to do the product or quotient rules. So log of base 2 of 5, we're going to have 5 to the power of 2 now instead. Everything stays the same. Now we're going to have addition between them. And for us to do the product law, we need to make sure that these numbers are the same. So only if they are the same can we apply the product law. So log of base 2, we're going to rewrite 5 to the power of 2 as 25. Now the product law, because of addition, that means that I can multiply the 25 times the 6.4. And that's going to be equal to log of base 2, 25 times 6.4 equals 160. So this is my simplified answer, and then I'm going to put that into my calculator by pressing alpha window number 5. So alpha window 5, you can then write the base of 2 and then 160, and then you should get it wants it to 3 decimal places, 7.322. Our next one, log of base 5 of 100, we're going to bring that 1/2 up, so it's going to be 5 and then 4 to the power of 1/2. So 4 to the power of 1/2 is just like square rooting a value. So we're going to write and simplify that 4 to the power of 1/2 by square root of 4 is 2. So that's the same as 4 to the 1/2. And because of subtraction, we are going to divide the 100 and the 2. So as long as the bases are the same. So as you can see, these two bases are identical, which means that I can do this quotient rule. So the base is 5, and then we're going to take 100 and divide it by 2. So what we're evaluating is log of base 5, 100 divided by 2 is 50. So in your calculator, you can put log of base 5 of 50 is, so we would put alpha window 5, put that into your calculator, and you should be getting 2.431. So this is the simplified answer, and then what I boxed in with a rectangle, that is my my solution. So that's the evaluation of it to the nearest thousandth. In this one here, I can bring that 5 up. I can go log of 27, and the 27 is going to be to the power of 5 instead. So what we're evaluating is 27 to the power of 5, and we get this large number, 143,48907. So this is what I'm putting into my calculator. Log of that number is equal to 7.157. These ones I cannot simplify. I can't simplify this. The reason being the 2 and the 5, the bases are not the same. So if the bases are not the same, I cannot use the product or the quotient rule. In this example, I'm going to rewrite it by going log of, I'm going to write 4 log of 8 divided by 7 first. And then what I'll do is I'll bring that 7 in front and write it as 4 over 7 log of 8. So that still means the same thing. I write it like that because then using the power rule, I can bring that up. Log of 8 to the power of 4 over 7. So in my calculators, I can evaluate this part right here. So what is 8 to the power of 4 over 7? So that would be 3.28. So I'm going to put that into my calculator. So actually, that's going to be what the whole value is. So I can take that off. So log of 3.281. Let's find out what log of all that number is. And it should be 0.516 as my answer. Ln is just the same as saying log of base e. So this is the same thing as saying ln. So that's a natural logarithmic way of writing it. So we treat them the same way and we still use the same rules. Ln of 98, we're going to write it as the next one. 2 ln 7, we can write it as ln 7, and then this 2 we can bring to the power, so that's the power rule, and write it as 7 to the power of 2. So ln of 98 minus ln of 49, this is going to be the quotient rule where I can divide. I can take ln and 98 divided by 49 is equal to 2. So ln of 2 is what I actually need to put in my calculator. So you should find that ln button on your calculator. That's just 2 buttons above on, the on button. So ln, you're going to put 2 in your calculator and you should get 0.693. Example number 2, they just want us to write it as a sum and difference. So what you're going to do is you're going to write that log 2 of 32. For the sum, you just have to find 2 numbers that multiply to 32. So log of 2, you'd write it as 16 plus log of base 2 of 2, because 16 times 2 is 32, so that would be equivalent. Another thing you can do is difference. Difference is you need to find 2 numbers that would divide to give you 32. So for example, I can choose 64 subtract log base 2 of 2. The reason being is 64 divided by 2 would give me 32. So these are 2 different ways to write out log base 2 of 32, one with the sum, meaning addition, and one with a subtraction. Example number 3, we just want to summarize this or simplify this as a single logarithm. So step 1, if you ever have numbers in front, you need to bring them to the power using the power rule. And you need to make sure that they all have the base of 5 in this example to be able to put them together. The Next thing we do is we write log of base 5. Anything that comes after an addition sign, meaning this one and this one, their variables will go to the top of the fraction. So anything that follows an addition sign goes to the top. Anything that follows a subtraction goes to the bottom. Okay, and the last thing I can do is I can write z to the 1/2 as square root of z. So z to the 1/2 means square root of z. Those are identical. It's just another way of writing it. Okay, so that would be the equivalent simple single logarithm that represents what I started with. For b, same idea. You're going to bring the 7 and the 3 up. So you're going to go ln of x to the power of 7 minus ln of y plus ln of x to the power of 3 and y to the power of 3. So that 3 belongs to the x and the y, so I had to apply it to both. Now, just like in the previous case, we're going to write ln. Anything that follows an addition sign goes to the top of the fraction. So x to the power of 7 goes to the top, and x3 and y3 also go to the top because they're following an addition sign. Anything that follows a subtraction has to go to the denominator, so that y needs to go to the bottom. And the last thing we're going to do is we're going to simplify by putting the x's together. 7 plus 3, because you can add the powers when it comes to multiplying bases, that would be x to the power of 10. And then y3 would be like writing y and y at the bottom. The reason I did it that way is these guys can cross each other off. The y from the bottom, y from the top, leaving you with, at the very top, x to the power of 10 and y to the power of 2 as your final answer. Okay, so that is your lesson 7.3, so your log laws. So that would be where this is